All right, so let's do another four input example. Four input K-map, that is. So I've already got all of our labeling done. This is always pretty much the same, right? The only thing that can really vary if we have four inputs is the names of our variables. So let's get to it. Like I said, this is the easiest way to do this is to label our rows in our truth table because it's super easy to just go and fill out where these ones are at now rather than saying A is a 1, B is a 0, blah, blah, blah. It's a lot easier to say, all right, here's row number 2 and here's cell number 2. So here's a 1. So I'm going to do that in black. So here's a 1. And we've got a 1 here. 7 is a 1. 8's a 1. 10 is a 1. 11 is a 1. And I think that's it. So one thing that you can kind of do to save time is just not put your zeros in. If you don't need them, you don't have to put zeros in. There might be something that you're doing later where you want to pay attention to zeros, but for just these vanilla K-map examples, it's kind of keeps things less cluttered if you don't actually put the zeros in there. So I'm not going to do that. Same thing with the truth table is sometimes it's tempting to just put the ones in there, which is a fine thing, especially if you're not really showing your work. That's not your final answer. If it is your final answer, you probably want to put the zeros in there as well. Same with the K-map. If you're just asked to just show the K-map, you probably want to have your zeros and ones shown. But if it's an intermediate step, then do whatever you got to do. Alright, so let's start finding our implicants here. So I'm going to circle my implicants in red. Actually, let's do a different color. Let's do purple. Okay. So we notice, I like to just pick a 1 and start building implicants around that 1. So here, I could circle here, and right, that's an implicant. But we notice that there's a neighbor right here, and this could grow there, and it would still be a power of 2, right? I'd have 2 1s. So that means I'm going to grow this way. And, right, we are kind of a little tempted to say, hey, there's this one over here, and there's this one, remember these share sides, so this one could capture this one over here. But no matter what, it wouldn't be a power of 2 size group. So that means that this right here is a prime implicant. It can't get any bigger. So let's go to our next one here. How about this guy? And we see that, of course, yes, we could circle like that. But it can get bigger. It could grow to get this one as well. And then the clever minds might notice that since these edges touch, right, we can't draw like that because they're confined to 2 dimensions, but these sides touch here, so that means that these ones are next to these ones. And so we can get an even bigger implicant that looks like this. And there we go. So that covers all of those ones. And then we got this one little lonely one just sitting over here. And of course, that kind of makes us think like, oh, that's kind of a small group. But remember, this top side touches this bottom side. So that means that we can actually make an implicant that goes like this. We can't stretch it any further, and we can't stretch it to this corner because that's not how our implicants work. They always got to be rectangle shaped, not diagonals. And that's it. That's as big as this, or that is a full cover, and that's as big as that implicant can get. So now let's write out what the values of each one of these implicants is. So let's start with this one right here. So let's see what stays the same. Well, we see that A, right, it's for this column, A stays as a 1 and B stays as a 0. So we can write A1, or A not, sorry. We don't not A because A is a 1, but we do not B because B is a 0. Ones are not knotted. Zeros are knotted. Now this is a little complicated because we got to jump around here. We see this implicant is in this row and this row. So let's see what changes in this row. Looks like C changes from a 0 to a 1, but D stays as a constant 0. So we're going to put D not. All right. So that's that implicant. Now let's look at this kind of big implicant here. So we see that A is a 0 here, A is a 1 here, so A changes. B is a 0, and it goes to a 0, so B stays the same. So we're going to put B not, since B is a 0. Now we see C stays as a constant 1. Right, C staying as a constant 1. And D changes from a 1 to a 0. So that's that term there. And now let's take a look at this guy here. A stays as a constant 0. So we got A not. And what else do we have? B changes from a 0 to a 1. So B changes, so we're not going to add that. And then we're stuck in this row here. So that means C stays as a 1. And D also stays as a 1. And there we go. Oh, one thing I forgot to do, just for completeness, is label my distinguished 1 cells. It's not necessary, but it can be handy, right? That's a distinguished 1 cell. That's a distinguished 1. And that is, and so is that. Right? We don't circle the ones that are caught in intersections. So that means that all three of those are essential prime implicants. Now our final thing for our function is to do this, right? To take all three of our terms and OR them together. X equals B not C, or A not C D, or A B not D not. Something you should notice is that the bigger your implicant, right, the bigger the group, the smaller its term. So the bigger the implicant you can find, the more it's going to simplify our function.